So let's do the integral of secant x times cosecant of x. There's no obvious substitution we can do just from looking at the integrand in this form, but we can try to rewrite the expression so we can do a substitution. Recall that the derivative of tangent x is secant squared of x, so if we could rewrite the integrand with a single factor of secant squared of x, and the rest of the expression as 1 in terms of tangent x only, we can do a substitution. We have secant x in the expression, so why don't we just try multiplying the expression by secant of x over secant of x, so we have a secant squared of x in the numerator. We could then see if the rest of the expression can be rewritten in terms of tangent x only. So if we multiply the integrand by secant x over secant x, the integrand becomes secant squared of x times cosecant of x over secant of x. We can keep the secant squared of x in the numerator the same because we need the secant squared of x to do the substitution, but we can rewrite cosecant of x in the numerator as 1 over sine of x, and we can also rewrite the secant of x in the denominator as 1 over cosine of x. Alright, so let's try to simplify this by multiplying both the numerator and denominator by sine of x so we can get rid of the complex fraction. So let's say we multiply sine of x over sine of x. If we do that, then the numerator simply becomes secant squared of x because the sine of x times 1 over sine of x just turns out to be 1. And in the denominator, 1 over cosine of x times sine of x is just equal to sine of x over cosine of x, and that's just tangent of x. So you can now see that the integrand contains a single factor of secant squared of x in the numerator, and the rest of the expression is in terms of tangent x since there's only a single tangent x in the denominator. This means we can do the substitution u equals tangent of x, which implies that du is equal to secant squared of x dx. And if we substitute this into the expression, the integral becomes the integral of 1 over u du, since we replace the secant squared of x dx with du, and the tangent x in the denominator just becomes the u in the denominator. The integral of 1 over u is just ln of the absolute value of u plus the constant of integration c, and since we let u equal tangent of x, this is just equal to ln of the absolute value of tangent of x plus c.